finite potential well. So V of R equals to minus V naught when R is less than R naught, and it is 0 when R is greater than R naught. And of course, they have considered this is a central potential. Okay, so we plot it. So along this axis your potential and this is your distance. So for plot of potential will be something like this. So here V will be V naught, and this is obviously R equals to R naught. Okay. So where will be the total energy of deuteron now? So it should be somewhere here, right? So this should be how much energy should be? Minus 2.25 MeV, right? Mega electron volt. Because its binding energy is how much? 2.25 mega electron volts. So of course its total energy will be minus 2.25. Now if you write time independent Schrodinger equation, so it will be minus h cross square by 2 mu del square by del r square E of R, and then you will have potential term, right? So this is your kinetic term. Then you will have potential term V of R, and of course there will be on centrifugal term because this is a central potential. So this will be L into L plus on h cross square by 2 mu R square, and then you will have U of R, right? And then you have E U of R, right? This is your time independent Schrodinger equation. What is mu here? Mu is the reduced mass of your system. Since this system contains one proton and one neutron, so it will be simply mp into mn divided by mp plus mn. And mass of proton and neutron are almost same, so you can write mp equals to n, almost equals to mn, right? So if you substitute it, reduced mass will become mp by 2. Okay. Now let us define this is your region 1 and this is your region 2. Okay. So that for region 1, in region 1, or you can say R less than R naught, that this equation, and of course this is your total effective potential, right? So this system will have minimum energy when L equals to 0, right? Because this term is contributing some potential energy, and for ground state that energy should be minimum. So if this term is minimum, so it will contribute least, right? Because this is all about your potential, and this term is that L can run from 0 to 1 to 3 like that. So when that L is 0, this will give you ground state. This will give you ground state. Okay. So now we'll substitute L equals to 0 for ground state, and we'll write that Schrodinger equation for region 1 or R less than R naught. So it will be simply minus h cross square divided by 2 mu del square by del R square U of R equals to how much? And of course there will be minus V naught, right? Minus V naught U of R equals to E U of R. Okay. And if you modified it, if you bring that V here, so it will become how much? it will become how much? So it will be simply
E plus V naught.
del square by del r square u r equals to minus 2 mu by h cross square e plus v, right? U of r,
Yes, sir.
right? So now we'll define this term. This I will write minus k square u of r. Okay.
सर
Yes.
मतलब यहाँ हम ग्राउंड स्टेट के लिए निकाल रहे हैं, इसकी वजह से हमने L0 लिया है ना, ऐसा कुछ नहीं है कि रेडियस के अंदर है इसकी वजह से, ऐसा कुछ नहीं है।
हाँ नहीं, रेडियस की बात नहीं है। देखो ये आपका पोटेंशियल एनर्जी टर्म है ना, तो ग्राउंड स्टेट
हाँ
मतलब मिनिमम एनर्जी है। तो अगर ये
हाँ
आपका देखो ये टर्म ये अब पोटेंशियल एनर्जी का वैल्यू ये आपका काइनेटिक टर्म, ये पोटेंशियल टर्म, ये आपका समथिंग, ये अगर मिनिमम मतलब ग्राउंड स्टेट के लिए तो ये मिनिमम होना ही पड़ेगा ना इसको, इस टर्म को।
करेक्ट है। हाँ
हाँ ठीक है। नाउ
इसी के लिए L0 लिया है ना सर?
एग्जैक्टली। नाउ this k square is how much? K square is how much here?
2 mu
plus
So
E
k
plus V by
square
H plus
equals to simply 2 mu h cross square e plus v naught, right?
सर माइनस भी होगा सर?
हाँ
नहीं सर, नहीं सर, ठीक है ठीक
माइनस नहीं होगा ना?
रूट नहीं होगा सर।
हाँ k, this should be k. Okay, this should be k,
Correct,
right? हाँ. So its solution will be, let us write u on r equals to a sin kr. And let us define this is your equation on. And for region 2, for r greater than r naught, what will be the Schrodinger equation? So it will be minus h cross square by 2 mu del square by del r square u of r, and that should be equals to how much? Minus
EU.
sorry, e of u. Okay. And if you rearrange it, so it will be del square by del r square u of r, and that should be equals to minus 2 mu e divided by h cross square u of r. Okay. Now I'll write this term. I'll write this term as a gamma square e of r, where gamma is how much? Minus root over 2 mu e by h cross square. Is it clear? Is it clear?
नेगेटिव साइन हम
Yes, sir.
इनसाइड ले रहे हैं रूट के।
हाँ मैं नेगेटिव इसीलिए ले रहा हूँ। देखो ये आपका एनर्जी क्या है, आपका एनर्जी क्या है? इटसेल्फ ए नेगेटिव क्वांटिटी। तो नेगेटिव माइनस नेगेटिव, इसलिए हम नेगेटिव डिफाइन कर रहे हैं, क्योंकि स्क्वायर रूट के अंदर अदरवाइज इट विल बी कॉम्प्लेक्स, राइट? Square root of negative, it will be complex, right? And this basically define that your direction of propagation. And if it is complex, then it will not define any direction of propagation. So you have to choose this factor such that square root should be some positive number. Okay. And if you see previous study, you see here I have considered e plus v naught, right? E is negative, but you see v naught is minus v naught is bigger than e, but v naught is bigger than e. That's why this term will bring positive number. Did you understand what I'm saying? Because
Yes, sir.
No sir, please.
didn't get
point.
See, you have this much of e, right? E
Yes,
is
sir.
negative, right? This much you have
Yes, sir.
minus b, but I am taking plus. Minus v naught is this much, then v naught will be how much? This much, right? Minus v naught is this
Yes,
much. If you take
yes.
magnitude, it will be this much, right? And
Yes,
this
yes.
is your e. So e will be
Yes.
v will be greater than e naught. So it will automatically give you a positive number. Now did you get what I'm saying? Because I have
Yes.
this is minus v naught, but v naught will be some big number, right? Positive. Did you get what I'm saying? Now can you write that solution of this equation?
Sir,
Can you-
exponent.
Exactly.
Yes, sir. Exponential e to the power minus gamma t.
So let us write this is your e to r, and that should be how much? B
E
exponential
to
gamma
minus
r
gamma t
plus
minus gamma r.
minus gamma r. So this is not r. So one is gamma, another is r. Okay. Now see, wave function is must
Positive.
vanish. Huh?
Yes, sir. Positive vanish हो जाएगा sir. Positive
This
वाला.
will vanish because wave function must be 0 at infinity, right?
Yes, sir.
Do you get what I'm saying? So if you apply boundary condition that u to r should be equals to 0 when r tends to infinity, right? So if you substitute r tends to infinity here, you see b to the power infinity, right? Plus d to the power minus infinity, that should be equals to 0. So it means b e to the power infinity plus d by 1 by infinity means e to the power infinity matlab infinity. So d divided by e to the power infinity means it will be 0, right? Automatically, because e to the power minus infinity is 0. So d into 0 equals to 0, equals to 0. So this b into infinity is 0. It means b should be 0. Did you get what I'm saying? Is it clear?
Yes, sir.
Everybody clear this step, what I'm saying?
Yes, sir.
Yes, sir.
Okay. So b is 0. Now your modified wave function will be u to r equals to c exponential, or sorry, c exponential minus gamma r, right? Is it clear? Or it should be
D exponential.
sorry,
No?
this is a this, let us consider this is your c, b, c. It's not sequence, right? So let us consider this is c. Okay, a, b, c. So it means your b is 0. Yes, b is 0. This means that wave function will be c exponential minus gamma r. Is it clear? Is it okay? Is it okay,
Yes.
right?
Yes, sir.
Now
Yes, sir.
we'll use that property of wave function. So wave function must be continuous, and its first derivative is also continuous. So if you see at
Sir,
boundary,
here in place of D you have written C.
because see a, b,
Oh.
c. So if you write
Okay,
a,
sir,
b, d,
okay.
it's not sequence, right? So it's good if you write a, b, c. Okay, is it clear? Now we'll apply that property of wave function. So wave function must be continuous. So if you see at boundary, or you can say write u1 r naught should be equals to u2 r naught. Okay, so this equation will give you how much? A sine k r naught equals to c exponential minus gamma r naught. Okay, is it clear? Now also first derivative is continuous, right? So what you can write, del y del r u1 r naught should be equals to del y del r u2 r naught. Okay, so let us give, this is your equation number 1, sorry 3. This is 4. And can you write, tell me what will be that value?
Sir, k cot kr0 equal to minus gamma.
Good. So आपका पूरा याद हो गया quantum mechanics का. Okay. So this will give you how much? On the left hand side, it will give you ka, then cos kr naught, right? Equals to how much? Minus gamma c exponential minus gamma r naught. Is it okay?
Yes,
Is
sir.
it okay, right? So let us give this equation number 5. So if you divide 5 by 4, how much you'll get? ये आपका कौन सा है? आपका 5, ये 5 है आपका, ये 4 है. So you will get k cos kr naught divided by sin kr naught. So it will be k cot kr naught should be equals to how much?
Minus
Minus
1
gamma.
upon C.
minus gamma, right? C will be vanish. This
sir,
C is
sorry.
gamma. Okay. Now if you multiply it by R naught, so it will give you K R naught, right? K R naught cot K R naught equals to minus gamma R naught. Okay. So you see, now we'll write that K. K was how much? Root over 2 mu E plus V naught, right? Divided by H cross square. No. Then you have R naught. Then cot, again K is there. So it will be root over 2 mu H cross square, 2 mu divided by H cross square E plus V naught. Okay. And you will have R naught, right? R naught should be equals to minus, what was gamma? Gamma was root over minus 2 mu H cross square, 2 mu H cross square into E, right? R naught. So this is your equation, right? This is your equation. Now we see, reduced mass is known, energy is known. Reduced mass is known, energy is known. R naught is the range of that force, and it is roughly the equals to the radius of that deuteron. So mu is known, energy value is known, that is minus 2.25 mega electron volt. This is mp by 2, and R naught is the range of this nuclear force, and it is roughly equals to the radius of deuteron, and its value is around 2.1 femtometer. So everything is known in this equation, only V naught is not known. So you can solve it mathematically if you put it in Mathematica. So in this equation, only unknown quantity is V naught. So if you put this equation and substitute this value in Mathematica or any computational tool, you will get that V naught. So now I'm writing this. mu is how much? mp by 2. E is how much? Minus 2.25 mega electron volt, and R naught is around 2.25 femtometer. So if you substitute it, you will get V naught equals to 36 mega electron volt. Also, if people have done this quantum mechanics finite potential solution, right? Graphical method. Everybody
Yes,
that done
Yes,
this,
sir.
right? So I'm giving you that homework. You have to do this because same thing you have done in quantum mechanics. Okay. So if you do this, put it in graphical method in quantum mechanics, so you will get this value. You please do it and show me. V naught R naught square equals to pi h cat square divided by 8 mu. Okay. 8 mu, then you will have what factor? 8 mu, we will get like
सर
this.
ए स्क्वायर सर
हाँ?
आर नॉट स्क्वायर तो उधर ही हो गया सर
ठीक है ना? V naught R
हाँ सर
square
यही है
equals
सर
to
Yes, sir.
ठीक है ना? सो ये आपका
यही
ये
है
मिला,
सर यही है
यही है, ये प्रूव कर सकते हो. सो दिस इज ए लाइक ए रिलेशन बिटवीन पोटेंशियल डेप्थ एंड रेंज ऑफ दिस न्यूक्लियर फोर्स. दिस इज
Sir,
ऑल. हाँ,
sir, may I ask a question, sir?
यस.
Sir, you are saying that if we put these values in the above equation which you have just told now, we are going to have this equation.
No, no, no. Previous
Then what?
equation only on unknown quantity is there,
Sir.
right? So you cannot
यहाँ-
solve. हाँ,
सर यहाँ पे एच कट ही है सर
ये
क्योंकि सर क्या ये 8 सर मतलब कि अगर वहाँ पे एच कट होगा तो फिर 8 कैसे होगा 2ma स्क्वायर होता है ना सर आई थिंक
नहीं, एच का टिस्कर है, एच का टिस्कर
Okay,
है,
sir,
बिकॉज
ठीक है,
आपका देखो आर
Okay, sir.
आर एक्चुअली कितना आएगा, पाई बाई 2 आएगा. ठीक है, तो आर स्क्वायर कितना है
हाँ, sir.
एक्चुअली? आर
हाँ,
स्क्वायर
sir,
पाई
sir,
स्क्वायर
ठीक
बाई
है, ठीक
4,
है.
राइट? एंड दैट
ठीक
विल
है,
बी
sir, हाँ,
सम
ठीक है, ठीक है.
ईटा स्क्वायर प्लस जाई स्क्वायर, राइट? ईटा
हाँ,
जाई इज
हाँ,
लाइक
ठीक है.
दिस. हाँ, ठीक है. you will get
वो
this.
सर वो भूल गया था ये
हाँ,
ऑर्डर का है ना सर। हाँ ठीक है सर, ठीक
ठीक है ना, you will get this.
ठीक है
बिकॉज
सर,
मैंने
ठीक है
डिस्कस
सर।
किया था अतुल सर से, तो बोले बच्चे सारे ने किया है,
यस
तुमको
सर,
करने
हाँ
का
सर,
जरूरत नहीं.
हाँ क्या हुआ सर।
ठीक है, नहीं तो मैं
ओके
करता
सर,
आपका.
ओके।
ऑलरेडी आई
नहीं
हैव
नहीं सर,
डन.
कर रखा है हमने।
इसीलिए सर
यस
ने
सर।
बोला है मेरे को,
और
क्योंकि टाइम स्पेंड ज्यादा हो जाएगा ना. चलो, तो ये आपका बेसिक ड्यूट्रॉन है ना.
ये सर
ठीक.
मेरा वाला डाउट सर।
हाँ, कौन सा डाउट आपका जी?
सर मेरा ये था कि ये जो क्वेश्चन क्या बोलते हैं, ये जो न्यूमेरिकल वैल्यूज हम लोगों ने लिया है R0 2.25
हाँ
V
हाँ,
नॉट, ये सब पुट करने से ये जो इक्वेशन ब्रैकेट में ये लिखा था वो निकलता है, मतलब ये क्या बोले नहीं समझ।
देखिए, अगर आपके पास दो अननोन, एक अननोन क्वांटिटी है, तो कितना इक्वेशन चाहिए आपको जानने के लिए? उसको एक इक्वेशन
एक
चाहिए.
अननोन, यस एक,
हाँ, दो एक अननोन क्वांटिटी है तो दो इक्वेशन चाहिए, है ना. तो यहाँ
यस
पे
सर,
अननोन क्वांटिटी कितना था? एक ही था, वी नॉट. आर नॉट
यस
नोन है,
सर,
ई नोन है, म्यू नोन है, एच कैट नोन है. ठीक है. और
यस
एक
सर,
इक्वेशन भी आपको डिराइव किया आपने, है ना. तो अगर एक
यस
इक्वेशन
सर,
में एक अननोन क्वांटिटी, तो आप आराम से निकाल सकते हो. बट दिस इक्वेशन इज सो कॉम्प्लिकेटेड by using computational tool like mathematica or other tool. ठीक है, density functional theory can easily calculate it. Okay, or Python if you know. Also,
oh it means, okay sir,
also there is a graphical method in quantum mechanics. Have you done this quantum mechanics class?
yes sir, last
So there is a
I
graphical method, right, for finite potential. This kind of form. I'm not spending time because Atul sir told me, I already taught them. This kind of plot you will see for tan pi by 2 like this. This will be at pi by 2, then 3
Yes,
pi
sir,
by
it
2.
is done.
That's why
This is
already
done.
have discussion, right? So this will be repeated. So this kind of plot you have seen. But from the point of intersection you can easily calculate.
सर एक बार एक्सप्रेशन आप लिख सकते हैं वो?
हाँ, लिख सकता हूँ. लिखो. V naught R naught square equals to pi h cat square divided by 8 mu naught, right?
बाहर है हम स्कूटी के
Can you
पास।
please mute your micro? Okay.
Thank you, sir.
Okay. Now we'll go to that radioactivity. Okay.
Sir,
Yes.
the
Yes,
ground state is mixture of L equal to 0 and L equal to 2, right?
yes. Yes.
So why we are not putting L equal to 2 here?
You see, there. You see that possibility you can understand now. There is 96% and only 4%. Okay.
Yes, sir.
Percentage is so less.
बट सर उसके लिए भी कैलकुलेट तो कर सकते हैं.
हाँ, कैलकुलेट कर सकते हो. फिर आपको वो करना पड़ेगा प्रोबेबिलिटी, बट उसका कंट्रीब्यूशन बहुत कम मिलेगा ना. 4% मतलब समझ रहे हो ना.
यस सर.
हाँ, कैलकुलेट ऑफ कोर्स कर सकते हो, बट कॉम्प्लिकेटेड हो जाएगा सॉल्यूशन. ठीक है, उसीलिए नहीं करते. कर सकते हो, वो आपका परफेक्ट रिजल्ट देगा, है ना. ये परफेक्ट, ये आपका रफ एस्टिमेशन है. ठीक है.
Yes, sir.
हाँ. नाउ विल डिस्कस रेडियो एक्टिविटी. So what is radioactivity? What is radioactivity? The nuclei which are unstable, they emit alpha, beta, gamma to become stable. So many nuclei are there. I'll write one by one and I'll tell also that region. So the nuclei which are unstable, they will emit alpha, beta, gamma. There are three kind of decay, and they will become stable. Okay. And that radioactivity is basically spontaneous process, right? NOS process. Okay, so there are 5 kind of decay. Okay, then I'll take example and reason. So first is alpha decay. Okay, in alpha decay, suppose you have parent nuclei, its atomic number is Z, mass number is A, decay to daughter nuclei Y, its mass number will be Z minus 2, atomic number will be Z minus 2, mass number will be A minus 4 plus alpha, right? Helium 2,4. So reason for this decay is, what is the reason? Size of nucleus is too large. ठीक है, हम लोगों ने डिस्कस किया था, अगर आपको याद है, बाइंडिंग एनर्जी वर्सेस न्यूक्लियन कर्व, राइट? मास नंबर, राइट?
Yes.
This we have discussed, and we have observed that when mass number is very high, then its binding energy is less, right? So this means they are weakly bounded, or they are almost unstable. So they will emit alpha decay, and they will come to higher binding energy or low mass number. Okay, so when the size of this nucleus is large, then binding energy will be less, and that's why they are unstable. They will emit some alpha particle, and they will try to become stable. Second is beta minus. Okay, so in beta minus, again I am taking some parent nuclei, mass number J, atomic number J, mass number A. So it will become decay, beta minus decay. So it will be mass number, atomic number will be how much? Beta minus atomic
Z plus 1.
exactly.
plus 1.
A, then you will have minus 1.
Minus 1 is 0.
What is the meaning of 0?
Positron, no, electron.
See, this is mass number, right? This mass number will be 0. No, you can write, you can see that notation now. Then there will be on another particle. What will be that?
Neutrino.
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 Is it neutrino? Southern?
Anti-neutrino.
The anti-neutron.
Anti-electron neutrino. Okay, there are 3 kind of neutrino. And what is the reason for this? Did you get now? Anti-electron neutrino, because electron should be conserved, right? This is electron number 1, this is minus 1, so it should be conserved, right? Swatan, we have discussed.
Yes, sir.
So what is the reason? See here, on proton is converting to become stable, on neutron is converting to proton. So you are getting, we are getting on additional neutron. So when that system will have excess neutron, then it will emit beta minus. If you remember, I taught you this kind of N versus Z curve. Okay, this is your stability curve, right? This is your stability curve, and this is your N equals to Z line. So up to calcium, if you remember 2040, that this curve will follow N equals to Z line. I mean, a state line for stable nuclei will follow N equals to Z line up to mass number 40. After that, increment of N will be large as compared to Z. Okay, suppose आपके पास एक न्यूक्लियाई है, कार्बन 614 है, so now it will become 714 plus your beta minus, and I am not writing, you can write Newton also. Now see, देखो आपका ये कहाँ पे लाई करेगा? यहाँ पे आपका क्या है? सपोज ये आपका यहाँ पे लाई करेगा, लाई करेगा somewhere, right? It will not lie on the stability curve. यहाँ पे आपका लाई करेगा, है ना? तो फिर क्या करेगा? यहाँ से आपका क्या करेगा? बीटा माइनस इमिट करके स्टेबिलिटी कर्व को अचीव करेगा. अब यहाँ पे देखो, आपका एन इतना था पहले इनिशियली, न्यूट्रॉन, अब कम हो गया. प्रोटॉन कितना था? इतना था, अब प्रोटॉन बढ़ गया. डिड यू गेट व्हाट आई एम सेइंग? Is it clear to all?
Yes,
Or
sir.
shall I repeat?
Yes, sir.
Initially, it was not on the stability curve because you see now n is large as compared to z. So it will try to achieve this stability curve by emitting beta minus, and beta minus, in beta minus what will happen? N will be less, so you can clearly see n is becoming less and z will be large. Is it clear? So a beta minus emission will always occur when there is a excess neutron, excess number of neutron. Is it clear? Again, beta plus, in beta plus what will happen? Are you people enjoying class?
Yes, sir.
किसी का
Yes,
कोई
sir.
डाउट है तो पूछ लो. इधर हाँ यस.
बीटा माइनस में मतलब जरा बताओगे कि बीटा 1 माइनस ऑटोमिक मास नंबर भी 1 आएगा कि
हाँ
मतलब इसमें इसका बीटा माइनस जब हम लिखेंगे ना तो उसको सिर्फ ऑटोमिक नंबर ही आएगा ना.
atomic number. Yes.
I can't
This
say.
is actually charge, you know. That's what I am writing minus. And you know, it's, mass of electron is almost negligible as compared to proton mass or neutron mass, right? So that's why we are writing 0. हाँ
सर बीटा माइनस में तो इलेक्ट्रॉन डीके होता है ना.
तो वही तो लिखा हूँ, चार्ज इज माइनस. यस तो यही तो है, माइनस ऑन इज 0.
Okay, one neutron is converted into electron and antineutron.
See, this particle will come.
Okay, one proton is converted.
Huh?
One proton is being converted, na sir, here.
See, one neutron is converted to proton. So you see, in the equation, atomic number should be conserved, or you can say charge number conserved. So atomic number on the left hand side z, here z plus 1 minus 1 z. Mass number also you can see conserved. Now neutrino, why neutrino will come? Because in particle physics we have discussed that electron lepton number is conserved, right? It should be conserved. This is a part of particle physics. So electron lepton conserved means on the left hand side equals to right hand side. So here no lepton particle is there, so it should be 0, and right hand side for y it will be 0. For this it will be on. So of course for this it should be minus 1, and that corresponds to your antineutrino. So for any decay, z number, a number should be conserved for any reaction. So here z plus 1 minus 1 z. Is it clear now? Or you are asking
Yes,
different?
sir.
Sir, here
Now it
a
is clear.
neutron is converted into proton, right?
Yes.
क्योंकि एक्सिस में है इसलिए.
हाँ एक्सेस है ना, वो
Okay,
ग्राफिकली
sir.
मैंने आपको समझा रहा था. ग्राफ समझ में आया?
Yes, sir.
वो
Yes,
कहाँ?
sir. Yes,
हाँ,
sir.
हाँ. इसमें क्या होगा बताओ? Z A. ओके तो y क्या कितना हो जाएगा आपका? Z माइनस 1 A प्लस
सर इसमें
पॉजिट्रॉन.
न्यूट्रॉन प्रोटॉन में कन्वर्ट हो जाएगा.
हाँ तो इसमें ठीक है. इसका रीजन क्या है बताओ? जब एक्सेस प्रोटॉन हो गया.
This excess of protons.
प्रोटॉन. ओके एक्सेस प्रोटॉन है. एक और है आपका इलेक्ट्रॉन कैप्चर. शैल आई इरेज एंड आई राइट? शैल आई इरेज?
Yes, sir.
एक आपका इलेक्ट्रॉन कैप्चर.
सर बीटा प्लस को ग्राफ से समझ सकते हैं.
हाँ समझ सकते हो आप. सपोज मान लो आपका कहीं यहाँ से कोई न्यूक्लियाई लाई कर रहा है ना, तो फिर बीटा प्लस इमिट करके क्या होगा? न्यूट्रॉन नंबर बढ़ जाएगा, है ना?
यस सर.
एग्जाम्पल भी ले सकते हो आप. सपोज मान लो आपके पास कार्बन 610 है, बोरोन में कन्वर्ट हो रहा है 510 प्लस एक्स्ट्रा, है ना? तो यहाँ पे कहीं पे लाइट करेगा, है ना, कार्बन 610. तो फिर वहाँ पे आपका ऊपर की तरफ भागेगा, तो न्यूट्रॉन नंबर बढ़ जाएगा, आपका प्रोटॉन नंबर कम हो जाएगा. सारे समझ सकते हो. ठीक है, आप थोड़ा ट्राई करो आप लोग भी. कैप्चर इसमें क्या होता है आपका? एक के सेल से ओके एक इलेक्ट्रॉन को कैप्चर कर लेते हैं न्यूक्लियस. ओके ई माइनस, एंड देन your atomic number will be z minus 1a, and of course there will be some what particle. So in this process electron from that inner shell orbit will capture by that nucleus, and if that electron will capture, then for the daughter nuclei atomic number will be Z minus 1. Okay, or you can write like this also, same symbol. Okay, Z minus 1, and there will be one particle. What will be that?
Sir, electron neutrino.
Exactly. So again, region will be how much? What region I'm writing here? Okay, region again you can say excess neutron. And last is gamma decay.
सर
Hmm.
सर इसमें न्यूक्लियस ने इलेक्ट्रॉन को ले लिया.
हाँ, सपोज मान लो आपके पास एक न्यूक्लियस है,
यस सर.
इनर सेल में इलेक्ट्रॉन है, इलेक्ट्रॉन will be captured by this nucleus. I'll
तो
discuss
प्रोटॉन
everything.
क्यों माइनस हो रहा है सर?
हाँ,
तो
माइनस नहीं होगा
Z
आपका यहाँ पे सपोज मान लो आपका 6 प्रोटॉन है, 6 का चार्ज कितना है? 6 प्लस 6 है ना? इलेक्ट्रॉन आ जाएगा तो 5 6 हो जाएगा ना, है ना? ठीक है. गामा डीके में क्या होगा? गामा डीके कब होगा? अल्फा बीटा डीके इमिशन के बाद ही होगा, है ना? अल्फा आफ्टर डीकेइंग सी there will be separate class for alpha decay, beta decay, gamma decay, but this is just basic introductory. Okay, so for gamma decay always happen after alpha and beta decay. So after decaying alpha and beta particle, nucleus will be in higher state. To become to come to the ground state, there will be emission of gamma. Okay, so it always happen after alpha or beta decay. Okay, तो इसमें हाँ
कैप्चर और बीटा माइनस दोनों में एक्सेस न्यूट्रॉन्स की वजह से हो रहा है.
हाँ, अब डिफरेंट वो हम डिस्कस करेंगे जब बीटा डीके में हम करेंगे कब आपका इलेक्ट्रॉन कैप्चर का पॉसिबिलिटी है, कब आपका उसका पॉसिबिलिटी है, क्योंकि हम बीटा माइनस का पूरा ये सारे क्या है ना आपका बीटा डीके को एक्चुअली बीटा माइनस बीटा प्लस एंड इलेक्ट्रॉन कैप्चर तीनों को बीटा डीके ही बोलते हैं. पूरा एक क्लास होगा उसके लिए. ठीक है, बीटा डीके का पूरा डिटेल्स में क्लास होगा, अल्फा डीके का होगा, गामा डीके का भी होगा. ठीक है
सर, गामा डीके के नीचे क्या लिखा आपने?
हाँ, गामा डीके आपका आप तभी पॉसिबल है आफ्टर अल्फा और बीटा डीके. मतलब ऐसा नहीं है कि गामा डीके अलग से होगा. जब अल्फा बीटा डीके होगा तब क्या होगा? न्यूक्लियस आफ्टर डीकेइंग अल्फा और बीटा पार्टिकल it will be in stable it will be in excited state. So to come to the ground state there will be emission of gamma particle. Is it clear?
सर ऐसा कुछ रेस्ट्रिक्शन नहीं है ना कि अल्फा डीके होने के बाद बीटा डीके होना ही चाहिए, और वैसा
नहीं ऐसा कोई रेस्ट्रिक्शन नहीं है, बट वो ऑलवेज दे विल ट्राई टू फॉलो स्टेबिलिटी कर्व, है ना? स्टेबिलिटी कर्व को अचीव करने के लिए जो करना है वही करेगा. ठीक है, ठीक है. तो इसमें क्या है आपका एग्जांपल क्या लिख सकते हो? ZA स्टार. स्टार मींस दिस न्यूक्लियर इज इन एक्साइटेड स्टेट. So okay, so it will be ZA, it comes to ground state and there will be emission of gamma particle. Region excess energy. Is it clear now? So this is all about your basic introductory. Now we'll.
So you have written A star.
Star means this nucleus is in excited state.
Oh, okay, sir.
So whenever you see that symbol, it means it is in excited state. So we should stop.
Last को gamma है ना?
We should stop here. Then we'll discuss after 5 minutes. Okay? Is it okay?
Okay, sir.
Okay. Suppose you have parent nuclei X decaying to Y. Okay. So initially at time t equals to 0, number of X nuclei is, let us assume n0. So after time t equals to t, let us assume that number becomes n because it is decaying to Y. Okay. So you can write like this is a parent nuclei. and this is your daughter nuclei. Okay. And then after time t equals to t plus dt, that number becomes n minus delta n. So rate of decay or rate of disintegration is written as dn by dt. It will be how much? Satan, it will be how much?
proportional to n naught.
इनिशियल
n
आपका n था ना, देखो n था, in time decay was how much? In time delta t, decay is how much? dln,
dn.
right? So it will be proportional to number of initial atom, right? So it is n, right? Did you get what I'm saying? So within delta t time, number of decay is delta n. Okay, so it will be, of course, it will be proportional to n. Is it clear what I'm saying? So initially it was at time t equals to 0, it was n0. At time t equals to t, number becomes n. After time t equals to t plus delta t, number becomes n minus delta t. So within this delta t time, decay is how much? Delta n. And it should be proportional to before decaying. And before decaying, it was how much? N. So it should be n. And of course, if you remove that proportionality constant, then it will be del n by dt equals to minus lambda n. Why minus? Because it decreasing that number of parent nuclei. Is it clear what I'm saying? Kuldeep, is it clear? Is it clear
Yes,
to
sir.
all?
Yes.
Any problem? So
No.
this is known as decay constant. This is known as decay constant. Okay. Also, this used to tell, or this is known as probability. अभी लिख लो क्योंकि अभी प्रॉब्लम दूंगा तब आपको करना पड़ेगा. Probability of decay in 1 second. ठीक है, क्योंकि अभी इस खत्म करके ही आपका प्रॉब्लम आएगा, है ना? साथ साथ प्रॉब्लम करेंगे हम. ठीक है. Now we can write
1 सेकंड होगा या यूनिट टाइम होगा?
हाँ in 1 second. 1 सेकंड में कितना होगा? ठीक है, क्योंकि यूनिट टाइम मतलब 1 मिनट भी लिख सकते हो ना. समझ रहा हूँ मैं क्या बोल रहा हूँ. बट हमें से 1 सेकंड में कितना डिके होता है इसका प्रोबेबिलिटी वो बोलते हैं. ठीक है. Is it clear what I'm saying?
Yes.
Now we can write like this, right? dn by n equals to minus lambda dt. Right. So now at time t equals to 0, and let us see at time t equals to t. So at time t equals to 0, the number was how much? N naught, right? Is not it?
Yes, sir.
At time t equals to t, let us assume, or we have written that is n as a function of time. So if you solve this, so left hand side it will be natural log of n by n naught equals to minus lambda t. So it means n equals to n naught exponential minus lambda t. Okay. So this is the n is what actually? Anyone? N is what here?
Number of
Number of atom after time t.
time t.
Anyone?
Number of particle after time t.
Number of undecayed nuclei, right? Undecayed. undecayed parent nuclei, you can say. यही तो है.
Yes.
ठीक है. So you can see that parent nuclei, that number of parent nuclei decreases exponential with time. Half life किसको बोलते हैं? What is the definition of half life?
Sir, one minute, sir. ये right hand side वाला, sir.
आपको बोल रिपीट करना है?
No, sir. रब नहीं,
Okay,
sir.
okay, okay.
एक
ठीक है.
हाफ लाइफ सर हाफ कंसेंट्रेशन हो जाना है इनिशियल से.
Concentration, हाँ बोल सकते हो.
नंबर्स का हाफ हो जाना मतलब.
हाँ मतलब number of undecayed nuclei n will become n naught by 2. Okay. At time t equals to t half. So half-life time means the time at which number of parent nuclei will become half of its initial value. Okay. Now if you substitute it here, it will be n naught by 2 equals to n naught exponential minus lambda t half. Okay. So n naught will be gone. So if you take natural log, so it will be ln 2. Okay, shall I erase this side? Shall I erase now?
Yes, sir.
Yes.
Okay. So now how much you will get? ln 2 or natural log 2 equals to lambda t half. So t half will be how much? Natural log is 0.2, log 2 is how much? 0.693 by t half. Oh, sorry, lambda. Okay. So this thing you know. Now can you tell me? Can you please tell me number of undecayed nuclei after nth half-life? How much it will be? Number of undecayed nuclei after nth half-life.
So n by 2 to the power n.
Good. So how will can you able to derive it?
So we
Can
can
you-
put in the equation.
Exactly. Now time after nth half-life time means time is n into t half. No. Total time. Any number of undecayed nuclei after nth half-life time means total time, that is n into t half. No. Is it clear what I'm saying?
Yes, sir.
Yes.
Now you can write n equals to n naught exponential lambda t, and lambda is how much? 0.693 by t half, right? And here you can write n into t half. T half will be cancelled and it will be n naught into 1 by exponential 0.693 to the power n, right? So if you solve it, if you substitute this numerical value, this is exponential 0.693 is nothing but 2. Did you get? Is it clear?
Yes.
Is it clear? So this should be n naught, right? Please write it n naught.
Sir, nth half-life means what, sir? The half-life to half, nth half-life.
So after 1 half lifetime number become how much? Undecayed nuclei? N naught.
N naught by.
After
Yes,
second half lifetime it will become n naught by 4.
Oh, okay, sir.
हमेशा आधा होता जाएगा, है ना, इनिशियल का. ठीक है. Also you can write that equation, this equation, n equals to n naught exponential minus 0.693 t by t half, right? So you can write like n naught 1 by 2 to the power t by t half. Okay, so if you know half lifetime for any time, if you know half lifetime at any time, you can easily calculate that number of undecayed nuclei. Is it clear what I'm saying? Is it clear? Suppose you know half lifetime, so they ask for a given time how much will be that undecayed nuclei. So you can easily calculate from here. Is it clear what I'm saying? Same thing I have written here in different fashion. So suppose this time is not integer of half lifetime. So simply you can substitute the time. If you know half lifetime, you can easily calculate. Is it clear? Is it clear?
सर,
For
एक बार
Yes, sir.
हाँ रिपीट करना है
repeat.
ये तो आपको पता है n इक्वल्स टू a नॉट एक्सपोनेंशियल माइनस लैम्डा टी. लैम्डा इज कितना है 0.693 बाई टी हाफ एंड टी है 0.6. देखो ये इसको अगर आप लिखोगे तो ये अब फिर से आपका क्या हो जाएगा 1 बाई एक्सपोनेंशियल 0.693 एंड ये आपका पावर में आ जाएगा, है ना. तो फॉर इफ यू नो हाफ लाइफ टाइम फॉर एनी टाइम यू कैन इजीली कैलकुलेट नंबर ऑफ अनडिकेड न्यूक्लियाई. एंड सपोज मान लो nth हाफ लाइफ टाइम बोला है तो nth हाफ टाइम के लिए कितना हो जाएगा, ये आपका कितना हो जाएगा टी के जगह पे n into t half.
N into T half.
Same thing I'm writing in different fashion. Okay, now I think you people got right. Shall I erase?
Yes, sir.
Are you people enjoying class? कोई doubt है class में?
No, sir.
Is it going good?
Yes, sir.
Okay.
Yes, sir.
Now can you if you plot this n versus t curve, so how it will look like, right? So initially it will be n naught, then at time first time at t equals to t half it will be how much, n naught by 2, right? At time t equals to 2t half it will be how much, n naught by 4.
Yes.
And so on. Okay, now mean lifetime थोड़ा जल्दी कर लेते क्योंकि प्रॉब्लम करना है, मेन तो प्रॉब्लम ही करना है ना. मीन लाइफ टाइम और एवरेज लाइफ टाइम आल्सो यू कैन से. Okay, so suppose you have again parent nuclei daughter and decay2 daughter. Suppose total you have n naught number of nuclei. In time t on, number of decayed nuclei is dn on. In time t2, number of decayed nuclei is dn2. Time t3, number of decayed nuclei is dn3. Then average lifetime, basically it's written is this symbol t bar. T bar will be how much? Sum of the lifetime of decayed nuclei. So it will be T on dn on plus T2 dn2 T3 dn3 and so on, divide by total number of decayed nuclei, dn on plus dn2 plus dn3 and so on. Okay, and in since this process is happening continuously, so you can write this like T dn divided by dn. Now we know that n, we know n is how much, n naught exponential minus lambda t. Okay, so dn will be how much, minus lambda n naught exponential minus lambda t dt. Okay, I'll just substitute it here. So you'll get lambda n naught t exponential minus lambda t dt divided by minus lambda n naught exponential minus lambda t dt. And initial time is 0 and final time is infinity. So
So
decay
we are
process.
finding average lifetime, right?
Yes, yes.
Okay, sir.
So this will be cancelled. Now can anybody tell me that value, this value? How much it will be?
And now, so 1 by lambda square.
Good.
So
Everybody
1 by
agreed?
lambda square.
This is a gamma function, right?
Yes, sir.
Okay. So you have to substitute lambda t equals to z, and if you solve it, the gamma function. I'm not doing. If anybody has question, you can ask me after class. Okay. So gamma function. This is also gamma function. So if you solve it, it will be 1 by lambda square divided by 1 by lambda. So it should be 1 by lambda. Is it clear? So t average life is how much? 1 by lambda. Is it clear?
Yes, sir. Yes, sir.
So average life is 1 by lambda, and 1 by lambda was how much? Lambda was how much? 0.693 by t half, right? No. So if you solve it, you will get on average lifetime or average life will be t half equals to 1.44 t half. Is it clear? Is it clear?
Yes, sir.
Shall I erase? ये वाला तो erase कर सकते हो ना डेप्थ पार्ट. Shall I
Yes, sir.
erase? रेडियो एक्टिविटी से एक क्वेश्चन आता है आप लोगों का जनरली. ठीक है, इस बार तो बहुत इजी क्वेश्चन आया था. थोड़ा सा कैलकुलेशन था, मैक्सिमम स्टूडेंट कर नहीं पाया.
So it is 1.44.
1 by 0.693 you can calculate. It will be
Okay,
1.44. ठीक है. अब है एक्टिविटी. Basically denoted by A. So activity is nothing but rate of decay or number of decayed nuclei per unit time. Okay. So dn by dt, and you know dn by dt is how much? Minus lambda n naught exponential minus lambda t. Okay. So it will be simply lambda n naught exponential minus lambda t. And lambda n naught is basically initial activity, A0. So you can write A0 exponential minus lambda t. So you can clearly see that activity of our sample is also decaying exponentially. So activity means number of decay per unit, number of decay per unit time. And it is obvious that if you are increasing time, number of nuclei is getting decreased. So number of decay nuclei will also getting decreased. Okay. Is it clear what I am saying, or you have any question?
The last statement, sir, can you explain?
हाँ, देखो जैसे जैसे टाइम जा रहा है, when you are going increasing the time, so number of nuclei becoming less, right? So if your
Yes,
number
sir.
of nuclei becoming less, so then rate of decay will also become less, because आपका number क्या हो गया, less हो गया ना, तो उसके बाद क्या होगा, rate of decay कम हो जाएगा. Is it clear now what I am saying? पहले
Yes, sir.
और क्लियर नहीं है तो बताओ. Shall I explain more?
No, sir, clear.
Okay. So basically it is measured in what unit? What unit that activity measured? Becquerel, right? Okay. Symbol is GQ. So 1 becquerel means 1 decay per second. Also it is measured in Curie. Okay, and on Curie equals to how much? 3.7 into 10 to the power 10 decay per second. So you can say on Curie equals to how much? This will be helpful when I'll solve that problem. 3.7 10 to the power 10 becquerel. Okay.
सर ये बेकरल का दोबारा मतलब बता दोगे सर, वो मेरी
हाँ,
खत्म
एक
हो गया था
बेकरल
मेरा।
का मतलब एक डिके 1 सेकंड पे एक डिके होगा, है ना। और
ओके
क्यूरी
सर,
जो
ओके।
है 1 सेकंड पे कितना डिके होगा, 3.7 × 10⁻10 और डिके
सर
पर सेकंड। हाँ,
सर 1 DK का क्या मतलब है, 1 DK?
मतलब एक न्यूक्लियाई 1 सेकंड पे डिके होगा, 1 सेकंड पे ओनली एक न्यूक्लियर डिके होगा।
ओके सर।
हाँ। Now radioactive branching. What is radioactive branching? What is radioactive branching? Suppose you have, now you saw what, see, most of the cases a parent nuclei is used to decay to daughter by only one process, either alpha or beta or gamma, right? But कुछ न्यूक्लियाई में क्या होता है कि एक न्यूक्लियाई दूसरे डॉटर न्यूक्लियाई में कई प्रोसेस में जा सकता है, बट ये बहुत रेयर है। सपोज योर पेरेंट न्यूक्लियाई इट इज गोइंग टू daughter nuclei by emission of at the same time. At the emission of alpha decay, suppose its decay constant is lambda alpha and it is giving y daughter. So X particle is decaying to Y by the emission of alpha. Also it can go to Z daughter nuclei by the emission of beta particle. So here I am writing alpha, here I am writing beta, and the decay constant is lambda b. Okay. So इस टोटल डीके कांस्टेंट कितना रखोगे इस डीके में, एक पैरेंट न्यूक्लियाई से डॉटर न्यूक्लियाई में जाने के लिए y के लिए कितना है डीके कांस्टेंट अल्फा, लैम्डा अल्फा। इस प्रोसेस के लिए लैम्डा डीके, लैम्डा बीटा। तो टोटल डीके कांस्टेंट कितना होगा एक पैरेंट से डॉटर जाने के लिए, दैट विल बी लैम्डा इक्वल्स टू लैम्डा अल्फा प्लस लैम्डा बीटा। X is going to daughter, parent is going to daughter by two process. In most cases, used to happen in single process, but in some nuclei, it used to happen many processes like alpha decay, beta decay. So if something is happening like this, so total decay constant for this decay process from the parent to daughter, you have to consider sum of the decay of alpha, decay constant of alpha particle and beta particle.
सर
हाँ,
सर अगर 2 DK एक साथ हो रहे हैं तो उनका तो मतलब कि एक्टिविटी चेंज होता रहेगा ना कॉन्स्टेंटली, एक्टिविटी की वजह से लैम्डा चेंज नहीं होना चाहिए सर।
लैम्डा, ये लैम्डा ऑफ कोर्स चेंज हो जाएगा।
तो फिर
लैम्डा
सर
चेंज,
हम इन्हें सम कैसे कर सकते हैं, मतलब एक टाइम पे?
देखो इसी से सपोज मान लो ये आपका डीके क्या है, आपका टोटल सपोज मान लो लैम्डा का मतलब क्या है 1 सेकंड पे कितना डीके हो रहा है ना, डीके प्रोबेबिलिटी यू कैन से, ठीक है। तो आफ्टर dt टाइम पे इसका प्रोबेबिलिटी कितना होगा अल्फा डीके का, लैम्डा अल्फा इंटू dt, ठीक है। और इसी टाइम पे आपका आपका जो आपका बीटा पार्टिकल का प्रोबेबिलिटी कितना होगा लैम्डा बीटा इंटू dt, क्योंकि 1 सेकंड पे प्रोबेबिलिटी कितना है लैम्डा अल्फा है और dt टाइम पे कितना होगा दिस। तो टोटल प्रोबेबिलिटी ऑफ डीके कितना होगा आपका लैम्डा अल्फा dt प्लस लैम्डा बीटा dt। ओके, प्रोबेबिलिटी तो ऐसे निकलते हैं ना, सम ऑफ द प्रोबेबिलिटी,
Yes, sir.
राइट, एंड दैट शुड
Yes.
बी लेट अस अज्यूम लैम्डा dt। So dt will be cancelled, you will get lambda equals to lambda alpha plus lambda beta. Now if you know, so you can write this like total in terms of half-life time. So 0.693 divided by t of half equals to 0.693 half-life of alpha plus, अभी प्रॉब्लम करूंगा समझ में आएगा। और यहाँ से प्रॉब्लम आता है, रिसेंटली गेट में क्वेश्चन आया था, बहुत कम लोग कर पाया, ठीक है। तो इसको कैंसिल करो ऑफ, सिंपली 1 by t half equals to 1 by t half alpha plus 1 by t half beta. Okay. Now we'll all do few problems. Are you ready, you people?
Yes,
Yes,
sir.
Okay. Please write the problem. Mean life of radioactive substance mean life of radioactive substance are 160 and 405. Oh, sorry, 1620 and 405 years for alpha and beta emissions respectively. Mean life of
After radioactive substance.
are 1620 and 405 years for alpha and beta emissions, comma, respectively. Full stop. Find the time during which three-fourth of a sample will decay if it is decaying both by alpha and beta emissions respectively.
तो मीन हाफ लाइफ दिया ना सर ये?
हाँ मिल रहा है, हाफ लाइफ दिया। आपने क्वेश्चन कंप्लीट लिख लिया?
यस सर।
When the time during which three-fourth of a sample will decay if it is decaying both by alpha and beta emission respectively. तो आपका क्या है, एक साथ दोनों ही इमिट हो रहा है ना, ठीक है? एवरीबॉडी रिटन क्वेश्चन? आप लोगों ने लिख लिया ना, ठीक है। अब करो इसको, कैसे करोगे? तो दोनों इमिशन एक साथ हो रहा है, तो फिर क्या करोगे?
सर मीन लाइफ इक्वल टू 1.440 हाफ के।
हाँ वैसे कर सकते हो, ऐसे भी कर सकते हो, लैम्डा अल्फा प्लस लैम्डा बीटा, राइट? और लैम्डा जो होता है 1 बाई मीन लाइफ, राइट? लिख सकते हैं हम इसको, अभी डिराइव किया था ना लैम्डा और हाफ के बीच में, नहीं?
यस सर।
And this thing you know, right? So 1620 plus 1 by 405. So it will, if you calculate, I have calculated, it will be 1 by 324.
324, yes sir, ये
Good. Now you can calculate.
yes sir. So 648 year.
Huh? See here they have, here they have said the time during which three-fourth of the sample is decayed. मतलब है decaying है, तो सी देखो आपको फॉर्मूला क्या है, नंबर ऑफ अनडिकेड है ना, इक्वल्स टू एन नॉट एक्सपोनेंशियल माइनस लैम्डा टी, राइट? दिस इज अनडिकेड। तो अगर थ्री-फोर्थ आपका डिके हो गया तो अनडिकेड कितना रहेगा? 1 by 4 एन नॉट, राइट? इक्वल्स टू एन नॉट एक्सपोनेंशियल माइनस लैम्डा टी, राइट? सो दिस विल बी कैंसिल्ड and you know lambda, right? So it will be ln4 or natural log 4 equals to how much? Lambda t, right? Then t will be how much? Natural log 4, then 1 by lambda will come, so obviously that factor will come 324, right? So if you calculate it, I have calculated, if approximately you'll get 449.
449.5.
Good, very good. Okay, you will get some fraction also. I'm writing approximate value. Is it okay?
Yes,
Is it
sir.
okay? Okay.
Yes, sir.
Shall I proceed?
दोगुना नहीं होगा सर?
हाँ?
सर, डबल
It
नहीं
is
होगा सर?
3/4
डबल नहीं होगा सर?
हाँ?
सर डबल नहीं होगा?
डबल कहाँ पे?
सर ये 1/4 बचा है ना, तो 1/4 मतलब अनडिकेट के लिए तो सर डबल होगा ना ये सर, 1/2 का तो डबल है हाफ का।
देखो कितना डिके हो गया आपका, 3/4, राइट?
ये
कितना
सर
डिके हो गया है ना?
ये सर अब बचा सर n0/4।
तो n0/4 ही तो
तो
लिखा
सर इसे
ना।
मैं, हाँ तो सर इसको मैं ऐसे भी लिख सकता हूँ 1/2 की पावर 2।
हाँ आप लिख सकते हो ऑब्वियसली।
तो सर ये डबल होगा ना सर? ये
कहाँ पे डबल होगा?
सर ये जो 324 को 2 से मल्टीप्लाई नहीं करेंगे क्योंकि टी हाफ का तो डबल, मतलब कि हमें और 2 गुना घटाना है ना सर?
जो भी करोगे यहाँ पे आपको यही बोल रहा हूँ ना, आप 1/2 स्क्वायर ना, राइट?
यस सर।
और 2 स्क्वायर आएगा ये आपका, है ना। तो 2 को इधर लेके आ जाओ, ln4 का जो वैल्यू है इसका वैल्यू सेम है, आप मल्टीप्लाई करो ना,
ठीक है
यहाँ पे
सर।
2 मल्टीप्लाई करो,
ओके सर,
इसका वैल्यू रखो,
आया
सेम ही
मेरे पास।
होगा, ठीक है ना।
ठीक है सर, ठीक है
योर
सर, ठीक है।
चॉइस। ओके, प्लीज राइट सेकंड प्रॉब्लम।
सर 3/4 का है ना सर, spend time during
3/4 आपका डीके हो
3/4
गया,
से
तो अनडिकेट कितना है, ये तो नंबर ऑफ अनडिकेट, मैं बार बार वही तो बोल रहा हूँ ना, ये आपका नंबर ऑफ अनडिकेट है, ठीक है। अगर
ओके सर।
3/4 मतलब इतना डीके हो गया आपका, तो अनडिकेट कितना है, n नॉट माइनस दिस, ठीक है। ओके, प्लीज राइट सेकंड प्रॉब्लम बिकॉज देयर आर मेनी प्रॉब्लम्स हियर। हाफ लाइफ ऑफ गोल्ड 198, half life of gold on 98 is 2.7 days. Question है, what is the decay
सर
constant?
कितने डेज है?
Half life दिया है 2.7 days.
ओके।
What is the decay constant? Second, B. What is the probability that AU 198 nuclei will decay in 1 second? What is the probability that gold nuclei will decay in 1 second? C. Suppose you had on microgram sample of gold, full stop. What is the initial activity? Suppose you had on microgram sample of gold, what is the initial activity? Option question D. How many decay per second will occur when sample is 1 week old?
When
Sir,
sample is
1 week old.
Sir, how many decay per second?
How many decay per second will occur when sample is 1 week old? Is it okay?
सैंपल इज कैसा कोल्ड सर?
Sorry?
सैंपल इज के बाद
1
कौन सा
week.
कोल्ड?
7 दिन. Sample is 1 week old.
Sir, can you
So
repeat
lambda
the
equal to
C
0.256.
question?
Sorry?
C part, can you repeat?
Suppose you had 1 microgram sample of gold, full stop, what is the initial activity? हाँ,
So
किसमें
lambda
कल
equal to 0.256 per day.
लैम्डा मत बोलो, डीके कांस्टेंट बोलो, ठीक है। 2.9
कौन सा है?
2 पॉइंट
सर 0.256 पर डे आ रहा है।
हमेशा सेकंड में कैलकुलेट करो, वही आपको सेकंड में पूछा जाएगा।
ओके सर, ओके सर।
हाँ, इस बार
2.9 into 10 to the power minus 6.
वेरी गुड। सो टी हाफ कितना हो जाए, हाँ कितना गिवन है 2.7 डेज, राइट। इट मीन्स आपको इसमें करोगे सेकंड में तो 24 into 3600, right? Okay, so if you calculate it, you will get 233,280 second, right? 233,280 second. Now you can calculate lambda. This is decay constant equals to 0.693 by 233. This is your effort 280, and this is of course that unit will be per second. So it will be 2.97, right? Or how much? 2.97 10 to the power minus 6 decay per second. What is the probability? Probability of decay per second. How much? So if you remember, I wrote this represent probability, right? Lambda.
Yes, 1 by lambda.
Lambda. If you see, lambda मैंने जब define किया था क्या किया था? Lambda is.
Yes sir, lambda yes sir, yes sir, lambda is.
So again, probability will be how much? इसलिए मैंने क्या बोला था उस टाइम कि प्रॉब्लम करने का टाइम आपको बोलना पड़ेगा सेम। Now can you please tell me that C part? Anyone? So initial
सर ये
activity.
डी पार्ट में सर क्या प्रोबेबिलिटी को हमने
डी पार्ट
ठीक
में
रखा? हाँ
deep definition of lambda itself, it represent probability of decay in 1 second. Okay, so this the definition itself is decay constant means probability of decay in 1 second. So same meaning of same.
ओके सर.
Can you tell me that C part? Anyone? And this kind of question you will get. C
Yes,
part.
sir. Sir, 2.97 into 10 to the minus 6 microgram per second.
2 point.
Sir, 2.97 into 10 to the minus 6 microgram per second.
No. You no. No, you always when you are calculating, not in gram, you have to calculate number of decay per second, because activity itself is saying that number of decay per second. So you have to calculate number. Now see, gold 198, right? So it means 198 gram contain how many nuclei? 6.023 10 to the power 23. No, right? Is it clear? From molar concept, right? Mass number corresponding to gram, that will contain.
एवोगाड्रो नंबर
हाँ, तो 1 माइक्रोग्राम कितना होगा आपका?
डिवाइडेड बाय 10 by 6 10 to the power 6.
6.023 10 की पावर 23 into 10 की पावर minus 6. नहीं? And of course there will be division.
by 198.
Good, very good.
198 आएगा ना?
Good, very good. Now can you able to solve? चलो आप लोगों को मैंने ये कर दिया, आप करो.
Sir, into lambda.
Lambda substitute करो. तो this is your n naught. So n naught into lambda. So 6.023 10 की power how much it will be? 17, right? Divide by 198 into lambda was how much? 2.97, right? 97 into 10 की power minus 6. आप कैलकुलेट करो, बताओ.
9 into 10 to the power 10.
9 into 10 or 9?
10
10 आ रहा है, देखो रिचेक करो.
Sir, 9 into 10 to the power 9.
9 आ रहा है.
गुड. तो आपका कौन सा यूनिट में आएगा बताओ? 9.03 10 की पावर 9. यूनिट क्या होगा इसका? क्यूरी, राइट? हाँ, डिके पर सेकेंड, दैट यू कैन राइट क्यूरी, राइट? नो, मैं आप लोगों को कंफ्यूज नहीं कर रहा हूँ. डिके पर सेकेंड क्या है एक्चुअली? बेकरल ना?
Becquerel is a Becquerel.
हाउ विल कन्वर्ट टू क्यूरी?
डिवाइड कर देंगे 3.7.
करो. अगर क्यूरी में पूछ दिया आपको तो बताओ कितना है. ठीक है, डिवाइड करके देखना आप. मैं लिख दे रहा हूँ आपको, चेक करना आप. 0.24. गुड, 0.24 क्यूरी. लास्ट वाला बताओ आप लोग. तो ये आपका बहुत सिंपल है, मैं नहीं करूंगा. ए इक्वल्स टू ए नॉट.
सर इनिशियल सैंपल n नॉट इनटू लैम्डा होगा सर.
हाँ, तो एन नॉट लिखा है ना, ये आपका जो नंबर है वो एन नॉट है.
यस सर.
हाँ,
तो सर n नॉट इनटू लैम्डा इनिशियल मतलब n इक्वल्स टू n नॉट e पावर माइनस लैम्डा t होता है ना सर?
नहीं देखो, ए इक्वल्स टू ए नॉट एक्सपोनेंशियल लैम्डा टी. तो इनिशियल
sir.
एक्टिविटी पूछा है. इनिशियल मतलब जब
A
शुरू.
naught.
ए नॉट पूछा है.
यस सर.
ठीक है, ये बस डी पार्ट किसने किया? कर लिया? एक्सपोनेंशियल माइनस
Yes, sir,
लैम्डा
कर
टी
लिया सर.
कितना है?
ये नहीं किया अभी.
अच्छा, ये कुछ नहीं, ये तो पता है आपको. 9.03 10 की पावर 9, राइट? एक्सपोनेंशियल ये कितना है आपका? लैम्डा कितना है?
2.97 into 10 to the
2.97 into 10
चलो
to the minus 6.
इसको ऐसे लिखते हैं 0.693 बाई टी हाफ. टी हाफ कितना दिया था? 2.7, राइट? ऐसे लिख सकते हैं इसको? नहीं,
Yes, sir. Yes, sir.
इसको कैलकुलेट करो 1.5 10 की पावर 9 बेकरेल आएगा. सेम यू कैन कन्वर्ट इनटू क्यूरी, यू कैन कैलकुलेट. नेक्स्ट प्रॉब्लम लिखो.
सर
यस.
यहाँ हमने जो फाइंड आउट किया है वो n नॉट इंटू लैम्डा है ना.
हाँ लैम्डा है.
तो यहाँ a0 जो हमने
ये वाला
जो
नहीं, एक्टिविटी आफ्टर 1 वीक बोले ना, डी पार्ट.
नो सर, ये मतलब n नॉट इंटू लैम्डा a0 कैसे आ रहा है ये जानना था.
ओ माय गॉड, ये वाला इनिशियल एक्टिविटी मतलब टाइम कितना है, 0 है ना. ये आपका एक्सप्रेशन आया था कि नहीं, a इक्वल्स टू n नॉट a इक्वल्स टू n नॉट लैम्डा इनटू एक्सपोनेंशियल माइनस लैम्डा t है ना. ये आया था नहीं.
यस सर.
ये क्या
Yes,
है,
sir, yes.
एक्टिविटी है ना.
क्लियर
ओके
क्लियर
सर,
सर.
ओके सर.
तो t इक्वल्स टू 0 पे कितना आ जाएगा, यही आ जाएगा ना. ठीक है, नेक्स्ट पार्ट करो आप. हाफ लाइफ ऑफ ए रेडियोएक्टिव आइसोटोप is 4 into 10 की पावर 8 years. Full stop. If there is 10 की पावर 3 radioactive nuclei present today, full stop, the number of nuclei in the sample or you can write calculate the number of nuclei. Please correct it. Calculate the number of nuclei present in the sample 4.4 into 10 की पावर 9 years ago. Half-life of a radioactive isotope is 4.4 into 10 की power 8 years. If there is 10 की power 3 radioactive nuclei present today, calculate the number of nuclei present in the sample 4 into 10 की power 9 years ago or back.
Sir, can you repeat one?
First line.
Half-life of a radioactive isotope is 4 into 10 की power 8 years. If there is 10 की power 3 radioactive nuclei present today, calculate the number of nuclei present in the sample 4 into 10 की power 9 years back or ago, whatever you can. Is it clear now?
Yes, sir.
Sir, half life is 4.8 years, na?
4 into 10 की power 8 years.
4 into 10.
How will do?
लैम्डा
t हाफ से लैम्डा निकल जाएगा सर.
n into t half equals to t मान. ठीक है, तो n equals to कितना है, t by t half कितना आ जाएगा. ये कितना दिया है, 4 into 10 की पावर 9 4 into 10 की पावर 10 सॉरी 8 कितना आ जाएगा, 10 आ जाएगा. ठीक है ना, 10 आ जाएगा ना ये. ठीक है, तो इनिशियल पूछे है ना. सपोज इनिशियली आपका के पास n था, कितना साल पहले, 4 into 10 की और 9 ईयर्स पहले आपके पास इतना था. फिर आपका डीके होकर कितना हो गया, n हो गया. ये गिवन है, n गिवन है.
5.4 into 10 to the power 5.
हाँ मैंने जस्ट पावर में लिखा हूँ सौतन, आप चेक कर सकते हो है ना. तो अगर आप लिखोगे n इक्वल्स टू n नॉट ऑन की पावर 2 टू द पावर कितना हो जाएगा, ये आपका 10 हो जाएगा, राइट. तो n नॉट कितना हो जाएगा आपका, n कितना है, 10 की पावर 3 है इंटू 2 की पावर 10. यही है आपके पास, यही है स्वतन. डू यू गेट दिस?
सर एक मिनट. नहीं सर.
सर 1 upon 2 to
सर
power
यही
10
आएगा
होगा
सर.
ना सर.
हाँ
सर यही आ रहा
सर
है.
1 upon 2 to power 10 है ना, तो 10 by 3 upon 2 to power 10 होगा ना.
ये आपका n गिवन है.
Yes,
देखो ये
sir.
n गिवन है ना, n कितना गिवन है, 10 की पावर 3 n नॉट 2 की पावर 10, राइट. So from here you can clearly write n naught equals to 10 to the power 3 into 2 to the power 10. Is it okay? Is it okay?
Yes, sir.
Yes, sir.
Okay. If it is okay, then we can go for next problem. Okay, please write that problem. A particular type of nucleus with decay constant lambda is produced at steady rate of P. Is produced at steady rate of P nuclei per second.
So can you just repeat?
Yes, a particular type of nucleus with decay constant lambda is produced at steady rate of P. Steady rate कितना दिया है? P nuclei per second. Full stop. Find the number of nucleus or nuclei. Find the number of nuclei present T second after the production. Find the number of nuclei. Find the number of nuclei, then you can write n of t also. Find the number of nuclei n of t present T second after the production. Then inside bracket please mention, given that when t equals to 0, n equals to 0. A particular type of nucleus with decay constant lambda is produced at steady rate of P nuclei per second. Find the number of nuclei NT present T second after the production inside bracket, given that when time equals to 0, number of nucleus is 0. Can you please able to solve it? So see, lambda is given me, it means this nuclei is decaying, right? Lambda is giving means this nucleus is decaying, right?
Yes, sir.
So decay rate will be how much? Minus lambda n, right? No?
Yes, sir. Yes, sir.
Production rate is given. So net or dn by dt, how much it will be? P minus lambda n.
lambda n plus Pn. Yes, sir.
Because this is production rate and this is decaying rate. No?
सर इसमें तो डीके रेट लिखा है सर डीके
डीके कांस्टेंट गिवन है तो इसका मतलब डीके रेट कितना है? माइनस लैम्डा n from previous study. Basic law of disintegration. And production rate is mentioned T. So from here you can clearly write dn by P minus lambda n should be equals to dt. Now you can integrate. When time t equals to 0, n is how much? 0, right? Then n when time is t. So from here you can write natural log of P minus lambda n by lambda should be equals to how much? T, right? Okay. So we can calculate from here P minus lambda n equals to exponential minus lambda t. Then you will get lambda n equals to P minus exponential minus lambda t. So lambda t n equals to how much? P minus exponential minus lambda t by lambda. Is it clear? Is it clear?
Yes.
सर लास्ट लाइन क्या लिखा है सर ब्लैक बोर्ड ने दिखा
हाँ n will be how much? P minus exponential minus lambda t by lambda. Okay, I should stop here. I have few more problems tomorrow we'll do, and then we'll proceed for successive transformation. Okay, shall I stop now?
थैंक यू सर
Welcome.
Thank you,
Sir,
sir.
गुड नाइट सर
Good night.